the discriminant. Consider the quadratic formula, which we know is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. The quantity under the square root is known as the discriminant, b squared minus 4ac. We give it the symbol with a triangle like this, delta. So delta is equal to b squared minus 4ac. This quantity is of great importance as it can tell us about the number and nature of the roots of a quadratic equation. For example, if we have x squared plus x minus 12 is equal to 0. So if we consider this one and compare it to the general quadratic, ax squared plus bx plus c is equal to 0, we can see that a is equal to 1, b is equal to 1, and c is equal to negative 12. So b squared minus 4ac is 1 squared, take away 4, times 1, times negative 12. So that's 1, add 48, remember the minus minus, which is 49. So in this case, b squared minus 4ac is positive. We can take the square root of a positive. So this tells me, in this case, that I'll have, so b was negative 1 plus or minus the square root of 49, which is 7, divided by 2 times a. That gives me two real distinct roots. Now we'll look at this graphically later, but what that means is if we plot the quadratic function, y equals this rather than solving the equation, that we'll actually get two distinct points at which the graph cuts the x-axis. Now for this second example, x squared plus 6x plus 9. So we can spot that a is equal to 1, b is equal to 6, and c is equal to 9. So we know that the discriminant is b squared, so that's 6 squared. Take away 4 times a times c, which is 36. Take away 36, which is 0. Now think about the formula we have. Negative b plus or minus the square root of delta all over 2a. So if this is 0, that just gives us minus b over 2a. What we consider there is we have two roots that are the same. They're called coincident roots. And we'll look at this later graphically, but basically that's a quadratic function, when we plot the function, that just touches the x-axis in just the one place. Remember, that's when we're plotting the quadratic function. Now let's look at this one. So we've got a is equal to 1, b is equal to 6, c is equal to 11. So that gives us 6 squared, take away 4 times 1 times 11, which is 36, take away 44. So that's negative 8. Under the square root we have negative 8, and we know that we can't square root a negative and get a real result. So in this case, we say there's no real roots of the equation. If we had the function graphically, we'd find that it doesn't intersect the x-axis at all. In summary, if delta is greater than 0, the discriminant is greater than 0, we get two distinct real roots. In other words, two different solutions to our quadratic equation. If it's equal to 0, then we get one real root, and actually we really think of that as being two coincident real roots, or a double root, basically two solutions that happen to be equal. If it's less than 0, then we get no real roots. There are imaginary or complex roots, but that's for later on in Mathematics Specialist.